Let's take a look at this example. We have given Z total and we're supposed to find the value of resistance and capacitive reactance. Because this is parallel circuit, we're supposed to find the total admittance first. Okay, so we have to find Y total first. Y total is equal 1 over Z total. So this is equal 1 divided by 3 kilo and angle of negative 55 degrees. This is equal 333.33 microsiemens and angle of 55 degrees. Next, we're supposed to convert the polar form to rectangular form. Okay, so Y total has to be changed to rectangular form. So let me just write everything step by step. So 333.33 microsiemens and angle of 55 degrees is equivalent to 191.19 microsiemens plus J 273.04 microsiemens, where this is my conductance and this is my capacitive susceptance, BC. Now, in order to find the resistance, I'm supposed to use the formula which says resistance is equal 1 over the conductance, 1 over G, which is equal 1 divided by 191.19 microsiemens, and this is equal 5.23 kilohms. Okay, so this is the value of my resistor. Next, I'm supposed to find the impedance of the capacitor. So I'm supposed to write that I have X of C equals 1 over BC. So I have 1 divided by my BC is equal to 73.04 microsiemens, and I prefer to work with polar form, so instead of J I'm going to write angle of 90 degrees. Use the calculator. You're supposed to obtain the value of 3.66 kiloohms and angle of negative 90 degrees. So this is my capacitive reactance. Someone can say, okay, I can keep going, but in our case we always like to verify our answers. So if I have resistance and I have capacitive reactance, I can find Z total and compare my Z total with Z total which is given. So let's take a look. This is parallel circuit, that's why I'm supposed to use the product over the sum. So I can say that Z total is equal R times X of C over R plus X of C. This is equal R 5.23 kiloohms times 3.66 kiloohms and angle of negative 90 degrees over 5.23 kiloohms plus 3.66 coulombs and angle of negative 90 degrees. Close parenthesis. Use the calculator and you're supposed to obtain the value of 2.99 coulombs and angle of negative 55.01. If you are going to compare this answer with the given value of my z total, you are going to see that they are almost identical, because 3 kilo and 2.99 kilo is almost the same value, and we have negative 55 degrees and negative 55.01 degree is almost the same. So it means that our calculations are okay up to this point. So next we're supposed to find the current which goes through the resistor. Before we are going to talk about the current, you're supposed to realize that in series circuit the current is always the same, right? But if it comes to the parallel circuit, the voltage is the same across each component. So I'm supposed to say that voltage source is equal VR, and this is also equal voltage across the capacitor. Current which goes through the resistor, IR, is equal voltage across the resistor over the resistance, where voltage across the resistor is equal 30 volts over the resistance. We found that resistance is equal 5.23 coulombs. Okay, so this is my voltage and this is voltage peak. Okay, we don't have phase shift. Okay, so that's why I'm going to have angle 0. I don't supposed to write angle 0 if I have voltage like that. So what I'm supposed to do, simply just perform the division. 30 volts divided by 5.23 coulombs is equal 5.73 milliamps. Okay, so this is the current which goes through the resistor. Next, we're supposed to find the current which goes through the capacitor. IC is equal voltage across the capacitor over X of C. Don't forget that we are talking about the parallel circuit. In parallel circuit, the voltages across each components are the same. So I have VC equals 30 volts divided by X of C, and we found X of C is equal 3.66 coulombs and angle of negative 90 degrees. This is equal 8.19 milliamps and angle of 90 degrees. Okay, so this is my current which goes through the capacitor. Again, someone is going to say, okay, I can keep going, okay, but the thing is, it's always good to verify that our answers are correct. So what we're supposed to do first? We're supposed to find I total using one way. So I have I total is equal voltage source over Z total is equal voltage source is equal 30 volts and Z total is given 3 coulombs and angle of negative 55 degrees. I total is equal 10 milliamps and angle of 55 degrees. So this is the one way to find the total current. Another one is simply KCL, right? Kirchhoff current law. So it means that if I'm going to add current which goes through the resistor and current which goes through the capacitor, I'm going to end up with the total current. So I have I total is equal IR plus IC, where IR we found is equal 5.73 milliamps plus 8.19 milliamps, an angle of 90 degrees. This is equal 9.99 milliamps, an angle of 55.01 degrees. So if you are going to compare this value with this one, you are going to see that they are very close to each other. So it means that the values of currents which we found are correct. Next, I can find the capacitance. Okay? So in order to find the capacitance, I'm going to use the formula for the capacitive reactance. X of C is equal 1 over omega C. You're supposed to solve this formula for C. So you have C equals 1 over omega X of C, which is equal 1 divided by omega. Omega is equal 1 times 10 to the 6 radians per second times X of C, which is equal 3.66 kiloohms. You're supposed to obtain the value of 273.22 picofarads. Okay, so this is the value of the capacitance in my circuit. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta. So I have cosine of the angle which is next to Z total. Okay, so we have cosine of angle negative 55 degrees. Okay, so this is equal 0.73, and I'm supposed to add the word lead. Again, someone is going to ask why I'm supposed to write the word lead, because the current in this circuit is going to lead the voltage source by angle of 55 degrees. Or anytime you see negative sign next to the angle, you're supposed to add the word lead. Next, we're supposed to find the equivalent series circuit. I mean the series circuit which is going to have exactly the same impedance like the parallel one. So what I'm supposed to do in this case? I take Z total, right, which is equal to 3K, an angle of negative 55 degrees, and convert this to the rectangular form. I have 1.72 kiloohms minus J, 2.45 kiloohms, where the real part is my resistance and the imaginary part is my capacitive reactance. So you can redraw the circuit and draw simply, this is my voltage source. Okay, this is of course the RS and this is X of CS. And I have RS over here and this is my X of CS over here. So where RS is equal 1.72 kilo and X of CS equals 2.45 kiloohms. Next, I'm supposed to find the true power. P true is equal 1/2, and the current which goes through the resistor, IR, square times the resistance. Again, someone is going to ask why I'm using 1/2, because I'm dealing with the peak voltage. I use peak voltage to find my currents. That's why my currents are peak currents. Okay, that's why I have to use 1/2. If we would have RMS values, you're not supposed to use 1/2. But in this case, we're going to use 1/2. So I have 1/2 times IR. We found the current which goes through the resistor, and it was equal 5.73 milliamps. We have to raise this to the second power times the resistance, and we found the resistance, it was 5.23 kiloohms. This is equal 85.85 milliwatts. Next, we're supposed to find the reactive power. QC is equal 1/2 current which goes through the capacitor raised to the second power times X of C, which is equal 1/2 IC is equal 8.19 milliamps raised to the second power times X of C, which is equal 3.66 kiloohms. This is equal 122.74 millivolt ampere reactive. Okay, so this is my reactive power. Next, I'm supposed to find the apparent power. S is equal 1/2 times I total raised to the second power times Z total, which is equal 1/2 I total we found, and it was equal 10 milliamps raised to the second power times Z total, which is equal 3 kiloohms. This is equal 150 millivolt ampere. Okay, so this is one way to find the powers. The other way to find them is using the values from my series equivalent circuit. What you're supposed to do is supposed to realize that the total current in this circuit is going to be equal to total current in my parallel circuit. Why? Because both of them have exactly the same total impedance. So you can verify, right, if this is true by simply writing the true power, right, is equal also 1/2, because I'm going to use peak value of my current, I total square times RS, right? Because right now I'm trying to find the true power in my series circuit. So I have 1/2, and I total is equal 10 milliamps raised to the second power times RS, and we found RS is equal 1.72 kiloohms. This is equal 86 milliwatts. So if you are going to compare this value with this one, we can say that they are very close. So if you want to check, let's say, reactive power, QC is equal 1/2, again, I total, because right now I'm talking about the series circuit, you have to remember that in series circuit, right, I total is equal IR, and this is also equal IC. Okay, so that's why I'm using always I total raised to the second power times x of c. S is equal 1/2 10 milliamps raised to the second power times x of c s, which is equal 2.45 coulombs, is equal 122.5 milli VAR. Okay, so as you can see, the values are, very close to each other. So it means that no matter what way you are going to use, if you are going to try to find the powers by applying the values of the components from the parallel circuit, or if you are going to calculate the powers using the values from the series circuit, the answers are going to be the same. So I can say that the problem is solved.